Hey guys, Chris from the Ultimate Recycler. Welcome back to the workshop. Welcome back to the channel. Welcome to another repair job. This is just a little one. It's a charger, battery charger from a Dyson stick vacuum. Now this belongs to my parents, to my mum and dad. I think mum actually won this vacuum in a competition or something. And it's a good one. I think they're about a $400 or $500 machine. It's the stick one. I think it's a model V8 or something, a current model. The charger goes in a wall mount thing, and so you just attach the thing to the wall and it charges up. However, I was home just last week and they said, no, it's not charging. It must have a fault. Maybe it needs a new battery, and it's not that old. So the first thing I did was just test any see if we had any voltage out of the charger plug, and no, there's absolutely nothing at all. I've plugged it in. We don't have any voltage. So there's no way known the battery is going to charge with no input voltage. I checked these out online. You can buy them new. You can buy them through Dyson. You can buy them on eBay. I think there's even aftermarket ones. The genuine ones are around about $80 or $90. Secondhand, they sell on eBay for about $30, including postage. Fluctuates a bit. It's a model, where are we? It's a model 205720-05. I think it suits quite a few models, and I think Mum and Dad's is the V8 version, which makes it sound like a really fast one. I'm going to pull this apart and see if we can fix it. Not only does it then save us having to buy a new one or even a second-hand one, but it saves this from going to the waste stream. Let's see if we can get into it. I expect it's going to be a bit of a challenge to break into the plastic. These things aren't made with service in mind, but we'll see if we can get into it, and we'll see if we can fix it. Okay, let's attack it and see if we can get it apart. Now there's a seam obviously around here. It's most likely glued. I'm just trying to see where it goes. Yeah, it looks like it goes right around here. So I'm expecting to make it, to give it a few war wounds, but there's no sense not trying, because it's either rubbish now or it will be rubbish in little bits later, or we'll fix it. This is a watchback opening tool. Actually, it's nice and strong, and it's not super sharp, which means that I'm unlikely to cut myself. And I think we might need to maybe even tap a screwdriver around there. We need to break the glue. I think it's going to be glued. I don't think it'll just be clipped. But wouldn't it be nice if they just made these things that you could clip apart and get into them without doing all sorts of scoring damage? I think that's going to come off that way too. Now it's certainly not clipped. We might just try a screwdriver into that section with a bit of a encouragement. Okay, let's try some thumps with a hammer, because sometimes this does less damage than trying to lever, because when you lever you sort of pry all the plastic. I'm using the hammer sideways so that I don't hit you guys in the camera. I don't have a lot of height room here now. Okay, I've moved it to the edge of the bench so that we don't squash the cord. And I'll try and get a little bit more hammering downforce. See if we can open up this gap. I might get rid of the mat because it's cushioning it. I want it to jar it a bit to hopefully break the glue. What if we use the case pack knife as a bit of a chisel? I think it's strong enough to handle that. Oh, I think that might be working. Alright, I do think we're opening the case up. I'll just work at this for a while. I'll be back with you shortly. Okay, it didn't take too long actually to get this side to start to crack. And I guess that's the glue letting go. I still haven't done most of it, but I thought you guys better watch this. So this side appears to be free now. and you can see that it's starting to lever up, or at least I can. But I've only really done a little bit along this side, so I think it's just a matter of working right around it. And it's not making too much of a mess, actually. I mean, it's going to be scarred, but it's holding together pretty well. There we go. Bit of a releasing noise. Yep, I think we're winning. There we go. So I think this is definitely glued, as opposed to some of the Apple ones. Apple charger, I tried to do an Apple charger a while back, and I think they remelt the plastic together rather than glue it. There we go. That wasn't so bad. Whilst it's still not super repairable, would have been easier to put 2 screws in it. That's come out without too much damage. Ooh, but I think there's damage in here. It looks like it's black. There's been a bit of barbecuing going on in here, I think. Let's try and slide this board out. But there's some charred looking parts. It might not be fixable. I wonder what's given up the ghost. Alright, how do we get this out? Oh, there we go. Alright, well that wasn't too bad to get into. What's going on here now then? Alright, we better just make sure there's no charge in these capacitors, but it hasn't been on the power for nearly a week. So I'm sure there's going to be no charge there. Just short across the capacitor terminals. No, that looks okay. Alright, something's given up the ghost here in a big way. The caps look okay, they're not bulged. It even smells burnt. Look at the black gunk I can wipe off that capacitor. So it looks to be something just here. I'm not sure what that is, but that might be what is. Oh yeah. Well, it's actually broken right off. So it's basically fused through that wire and blown that wire. I'm not sure what it looks like. There's a part here within some heat shrink tubing. I might have to cut that tubing off and see what that part is. But that's the part that's given up the ghost. The rest of it really just looks charred from the fallout. They were all standing around seeing what was happening, and they all got black faces when it went bang. Alright, I'll try and cut that heat shrink tubing off, and we'll see what part this actually is. And I wonder why it went bang. Alright, what I might also do, I'll get that off first, but I'll probably give the circuit board a bit of a clean up with some IPA and a toothbrush. The bottom of the board looks fine. So hopefully we've just got one component that chucked the towel in for no apparent reason. We might be able to replace it and get back into charging. Okay, it looks like it's a fuse. I thought it might have been a resistor. Ah, it's actually broken. So the fuse has gone in a big way. Wonder why they coated it in heat shrink. Oh, there we go, it's come right off. So I'll clean the board up and see if the board tells us what component it's supposed to be. But where's that camera? We can see that it's well and truly cactus. Well, at least we'll be able to, looks like there's some numbers on the end of the cap, so we'll be able to work out what it was, what sort of fuse it was. There we go, that's the end of the fuse. Okay, let's clean the board up first. Okay, that looks a bit better. We might try and scrape some of this white silicon stuff off and see what the board tells me that part's supposed to be. Okay, the board's cleaned up pretty well, and we can read there it says T2.5A. So T is the slow blow type fuse, 2.5 amp, 250 volt. So it's the tiny one though. I don't have any of those here, and we can confirm those numbers by actually reading. If we get a focus here, we probably won't. No, I won't bother trying. But the end of the fuse actually does say T 2.5 amp, 250 volt. But it's the tiny one. There are only 10 mil long, and they're I think 3.6 mil wide. We don't have a lot of room. I think I have a room for a bigger one on the board. These are the next size up here, which are 10 mil long, and I think they're 5 mil diameter. So I do have some of these in 2.5 amps, but they haven't got the leads on the end either. However, my dilemma, of course, is why did the fuse blow? Is it possible that something on the board has fused, as in shorted, and the fuse is designed to blow when that happens? It seems ridiculous to me to have a replaceable fuse, even though you'd have to solder one inside a case that wasn't designed to be opened. Anyway, regardless of that, if I replace the fuse, we'll have to try and test it while it's apart and see if it stays intact and see if the charger will supply the right voltage. And then we're going to have to load the thing up a little bit. I don't know how many amps or milliamps the batteries will draw on the actual vacuum. I don't want to put a fuse in here, solder it all, put the whole thing back together and take it back to the farm and then hook it up to the vacuum and suddenly it blows the fuse again. I should have probably brought the vacuum with me, but I didn't, and I won't be over there for another month. So I can temporarily solder a larger fuse in here. We'll plug it in, we'll power it up, and we'll load the output up with, I'll try and do some checking to see what sort of draw this vacuum cleaner would have. It's not going to be enormous amounts, but I guess if we can light up a light globe on the end of this without the fuse blowing, everything should be okay in this circuit. But the other thing, of course, that the fuse might blow straight away because something's shorted. So that's the first step to try, I think. Okay, I'm ready for a dodgy test. I decided not to solder a fuse in. I've just got a couple of test leads here. So it's 2.5 amp slow blow fuse across the same points on the circuit that the original one was soldered in. I've got an extension cord plugged in here, and also I was saying about the current draw from the vacuum. I don't need to know that because it says that this can deliver 700 and something milliamps, so we'll be able to power up some light globes or something to give it that sort of a test. But first of all, if we've got a direct short somewhere else, this fuse will blow straight away. So I'll turn the power point on. Hopefully it doesn't blow. That will mean we'll have to diagnose a faulty part on the board. Alright, let's plug it in, turn it on, see what happens. Oh, there we go. That wasn't a slow blow, that fuse blew big time. So now my workshop smells like fireworks. There's something that's a direct short on that board. I'll start my diagnosis by taking these wires off so they're not in the road. Now obviously the power's disconnected. I've shorted the capacitors again, and we'll remove the mains wires. Okay, we can move that out of the road, and I'm going to take the other wires off the other end, and they are marked positive and negative on the back of the board, so I'll know which way they go. And the first thing to probably test is to make sure those wires aren't shorted, just in case there's a short somewhere in this wire, because I would imagine that would blow the fuse. Okay, our board is clear now. Let's just check to make sure these wires aren't shorted. So no, we have open there, which is good, so there's no issues in that wiring or the plug. Well, that's ruling some of it out. So somewhere on this board there's a direct short where there shouldn't be. So we're going to I'll probably test the capacitors. I don't know that they're likely to do a direct short. Possibly a diode. What do we got in here? That would be a rectifier. Maybe the rectifier has an issue. So I should be able to test that. It's AC in from that side, DC out. So our mains comes in here, and then the link from that pad over to the rectifier was where the fuse was. So I have to try and test that rectifier. So we have a couple of little diodes in the circuit as well underneath, and there's a little IC chip in there. I'm not sure what that does. This big capacitor here, maybe we should check that one because that's connected across the side of the rectifier. So I gather it's a filter capacitor, but if that's a direct short, that will connect both sides of the mains, and that would certainly blow the fuse. So we'll just see if we've got any continuity across there, I guess. Across this side of the rectifier, what's going on? Oh, direct short. Is it the rectifier or is it the capacitor? I guess we'll have to lift one leg of the capacitor and see what's happening there. Sometimes find solder very hard to melt unless I melt some fresh stuff onto it first. We might do both sides. We might take the capacitor right out. Maybe that solder's difficult because it's modern lead-free solder, which by all accounts is pretty awful stuff. There we go. Alright, well, it's got a bit of soot on it from the explosion earlier. Maybe it isn't even a capacitor. I'm not sure what the numbers mean. Let's see if it's got a direct short or not. Okay, no, that's good. So I guess it's a filter capacitor, and it looks to be fine, or at least it's not shorted. We'll put that aside for the moment. So that leads us then, the next component is the rectifier, and I'm sure you should not have a direct short across that side of the rectifier. So let's take the rectifier off and we'll try and test that a bit more accurately. So I have the rectifier off now. It took a bit to get off. It looked like it was almost baked onto the surface. I don't know if that's normal, but I've got it off, and I've just tested it with the ohms meter for continuity, and we have every single terminal, if I get the leads on properly, every single terminal is a direct short. Every direction we go. So clearly this thing is toast. In fact, it's worse than toast. May as well have all 4 pins hardwired together with fencing wire. It's a direct short. Now, why that happened, I don't know. I guess the dilemma now is that, well, for a start, I have to find another rectifier. But did the rectifier blow because something else went? I mean, that's the trouble with circuits. They're all kind of interconnected. So we had a fuse blow because the rectifier was a direct short. But did the rectifier become a direct short because of some other overload? I don't know. I wonder if I can find a rectifier like this, maybe on an old second-hand circuit board I have here, or another power pack. They might be fairly similar. I'll try and get a number off it. It's very faint. All I can see is the symbols for the AC circuit on one side, and on the other side they have a plus and a minus. I'll look up a number. I'll have a look at some other boards I've got. I might have to do that tomorrow. And if I can find a good rectifier, we might solder that in, try another fuse, and see if we have more fireworks, or see if that fixes the problem. I guess I probably should just check a little bit down the line. The next thing is another big filter capacitor. So I better make sure that's not shorted. And, well, there's 2 actually. Oh, and then there's this coil. So I can check some of those things. I might as well check all the capacitors with my ESR meter to make sure they're okay. But yeah, I'll try and find a bridge rectifier next. Okay guys, it's 1 week later or thereabouts, and I have a packet of 5 new bridge rectifiers. I ordered them on eBay, and they're brand new, and that whole pack of 5 cost me under $5 including postage, so very low cost. So now I'll have some in stock here. Whether I ever use another one again is a matter for consideration, I guess, but you know, eventually I'm going to have a good stock of stuff and hopefully it will be useful. Now, what did I discover since I last spoke to you? I did look up what I thought was some sort of filter capacitor, and it's not. It's a MOV, or metal oxide varistor. So it's actually essentially a variable resistor which has extremely high resistance, so it's pretty much open circuit. It goes across the mains voltage coming in, but if it senses a voltage spike well outside its specs, the resistance automatically reduces a lot to make it almost a direct short. So it offers circuit protection, because what happens when that senses a voltage spike and shorts, it blows the fuse. So it's possible that if one of these units has a blown fuse, there may be nothing wrong with the actual board. It may have been a voltage spike and the varistor may have done its job and basically shorted the mains to blow the fuse. But that hasn't happened in this case, because our bridge rectifier is shorted. So whether that happened at the same time or whether the bridge rectifier was a faulty part, the numbers, I looked up the numbers on this one that I ordered, and they're rated at, I think, 1,000 volts and fairly high current. So I'm sure it wouldn't have blown just from a small voltage spike. Look, maybe there was a large spike and it took the fuse out and the rectifier at the same time. I'm not sure, but anyway, we're going to replace the rectifier. I have tested all the other components that I can. All the caps look to be okay. I couldn't see any other faults anywhere. So I'm going to replace these components. I found a fuse on another old power board. It's not 2.5 amps, it's only 2. But I think it'll be okay. In fact, the little power unit I actually got it out of, this had some other fault and I didn't need this for anything in particular, so I sacrificed it. Now this one was rated at 2 amps, whereas this one I think was only rated at 750 milliamps. So if the 2 amp fuse was fine in a power supply that can deliver up to 2 amps, it should be perfectly fine in this one. So we'll put a rectifier in circuit now. We'll put the MOV, or metal oxide varistor, back in. They're not, there's no polarity with those, so we don't need to worry about that. We'll put this fuse in, the 2 amp fuse. Now, can anyone tell me why most of these I've found have heat shrink tubing over them? The only reason I can think of is if the fuse does explode. I guess the heat shrink stops fragments flying around, but I'm not sure if it's necessary or not. But I think in the interests of replacing things as they were, I'll put a bit of heat shrink tubing over the fuse. We'll solder that back in and I'll be back to you shortly, hopefully with an operating power supply. Okay, everything went back together nicely. We're ready for a test. I haven't got the output wires on yet. We just want to actually test it with the mains going in and hopefully it doesn't blow things again. I did check the continuity across the mains and it's not shorted anymore, so hopefully there's no issues. Let's turn it on with no load and make sure it doesn't go bang. Well, it went bang. Why? I don't know. Did it blow the rectifier again? I don't know. Wonder if it blew the fuse. I've turned the power back off again. I'm not sure where that spark come from. Bugger, we're not there yet. Okay, this is stretching my brain cells. What's happened is we blew another fuse. The fuse is definitely blown. I've removed the varistor and it appears to be still fine. We have 100 ohms across the rectifier on both sides, and I just checked a new one and it should really read open circuit, and a diode rectifier bridge will allow current to only flow one way, and I'm getting 100 ohms both ways, so there's we've just blown a new rectifier. That's obviously why I've got a pack of 5 of them. Lucky I didn't order just one. So we've still got 100 ohms across the other side of the rectifier, so it's almost a direct short. It's not as a direct short as the last one was. I did check the capacitors in circuit and they seemed okay, but I might have to just start removing components because I really don't know what's going on. And if I just test each component as I go, we might trace down the problem. I'm not sure. I'm going to take the rectifier off here again and just see. We shouldn't have any connection here, but we didn't before when we had it off. So there has to be a fault causing the rectifier to basically short, which then in turn blows the fuse. We have an induction coil, like a filter coil on this side, which is the positive rail, I think. So that should be fine because it only really just allows current to flow through it to continue the circuit. I can't see a problem that coil will cause. This is another capacitor here, so they are across the voltage, so if one of them's got a partial short, that will be doing it. I tested them in circuit, as I said. Then it goes to an IC in here. Interestingly, all one side of the pins of the IC are soldered together, and they're soldered to a heatsink type shield as well, and there's only a couple of individual connections to the other side. I don't understand what that does. It's possible that that has an internal fault and it's drawing more current, which consequently is blowing these parts. It's going to be really hard to work out this. I'm not sure. I mean, logically I should have thrown it in the e-waste in the first place and just bought another charger, but I'm not about that. I like to try and solve these challenges, and I am learning. I've certainly learned a bit. I've learned what a varistor is, a metal oxide varistor. I've you know, the more you muck around with these things, the more you do learn, but it's very frustrating when you can't sort them out. I would have thought that would have been right to go now, but obviously not. So this job has rapidly spiraled into failure. I'll probably finish it up here, but I might just have a bit more of a play. I doubt I'll be back to you with this because I can't see things improving. What I've done is I've removed a few parts. When I did take the rectifier off, it actually started to lift the copper track, so that was a bit of a bugger, but as it turns out that probably doesn't matter so much. Let me get a pointer. So I've removed some electrolytic capacitors. They're all good as gold. We still have something like only 100 ohms across the power rails, which clearly is what's been overloading the circuit. That's just a coil, so that won't be a problem. So that capacitor's gone. I've taken the one from there. And that then leads us into this IC. Now, since I've removed the capacitors from the other side, we get a much better view of things. And I'm not sure how good the light's going to be here, but if we look at this, there's some black charring at the back of this IC that I don't think came from this fuse, because this capacitor with a big blob of silicon was actually sort of shielding that, and yet there's been some sort of eruption of soot, for want of a better term, out of this IC that's under that tin cover. So I think the IC has actually blown out, and I don't know why, and I think that's beyond my capabilities of fixing it. I think I'll just unsolder the cover and pull the cover off. The IC may indeed have a number on it, and I might fluke it that there's one on another board that I can swap over. But the trouble is, I'm getting into areas on this board that have microscopic little MLCCs, and my soldering isn't that good. I haven't really done much with surface mount stuff. So I think we'll probably call this one. You do have to know when to quit. I've certainly wasted a lot more time on it than what the power supply was worth. In fact, I knew that was going to happen. And I thought we had fixed it, but alas, the problem was deeper into the circuit. I don't know why that's happened. Dodgy part, perhaps, because the circuitry should be protected. It had the fuse and it had that varistor to kind of protect the circuit from voltage spikes and overloads. But yeah, that IC, you can see it's blown the leg out that side, and it's certainly had some sort of mini explosion go on there. So there's been lots of fireworks on this board. some that I've created and some that happened before I got here. So anyway, an interesting attempt at repair. We can't fix them all. Looks like I'm going to have to go online and buy a new charger for Mum and Dad's vacuum. As I said, I'll just take that tin cover off and have a look, but unless there's anything startling, I won't be showing you this again. Okay, I had to show you this. Hasn't this IC absolutely gone pop? There's black everywhere. Now, I'm thinking it's the IC. I don't think it's the transformer. But the end of it looks quite charred. So it's certainly got a big issue. I did just wipe the heatsink compound off the top with some IPA to read the number. I'll have a quick peek at the other power supplies I've recently thrown in the scrap bin. If there's one of those ICs in there, I might try and swap it out. I don't know, it'll test my soldering skills, but we'll give it a go. Well, call me pig-headed if you like, but I've decided not to give up on this power supply just yet. I've removed the chip, as you can see. Big burn mark underneath it. I had cleaned up around it before I removed it, and look at that. So I don't think it's come from the transformer. There's just a bit of a stain on the tape there. It's definitely been an explosion from this little chip. I did look up the number online, and I found a couple of forums referring to this chip on power supply boards. One was actually in a kitchen appliance, a gas hob, I think, something to do with the ignition circuit. I might have been an induction hob. That's regardless. He said it exploded as well, or it blew the top off it. And a few people commented that these chips do self-destruct. But whether it's the chip's fault, again, or whether it's something else on the circuit, look, there's really only, other than some really minor parts underneath, there's really only the transformer, and I don't think that's got an issue. So I'm going to bite the bullet and buy one of these chips. I'll probably have to buy them in a pack of 5 or something. They're very cheap though, and look, it's just, I like to try and have a win. I don't know, if it blows the chip, then I might throw the whole thing in the bin in disgust, but I'm going to give it a bit more of a go, which now means I've got to wait for a week or so until parts turn up. So I'll put it all aside and we'll get back to it then. So guys, we're back at the bench. It's been a few weeks. Well, for me, it's been a blink of an eye. For you guys, I have a new chip to put in this power supply. I have another rectifier here, a bridge rectifier. I have a new fuse. These are the components that I've blown up. Well, actually, in my defense, I didn't blow them all up. Some were like it when I got it. You'll notice I have them all upside down with their legs in the air because that signifies that they're deceased. I've cleaned the board up quite a bit. I did take another little capacitor out of here just to check it. It was quite charred on the outside, but yeah, it tests out fine. I have the little heat sink. I have these filter capacitors to put back in, and the varistor, and a little bit of heat shrink tubing to put over the fuse. I do have a question for you guys though. When I assemble this, I won't have all this white silicon around the parts that used to be. Is it necessary? What is it for? Perhaps I won't actually, assuming that we have success and have this thing operational, perhaps I won't fully assemble it until I find out if I should squeeze a tube of silicon all over it. Yeah, I wouldn't want to find out that I should do it for some sort of thermal reasons or something after gluing all the case back together. The other question I have for anyone that may know is, the fuse was a 2.5 amp slow blow fuse. The closest I can get is 3.125, so it's half an amp over. Is that going to be a problem? I don't want to put it back in with a higher rated fuse if it has a risk of catching fire. I just can't even get slightly under the 2.5 for some reason in this size. So this fuse over here, I think it's 3.125. So I'm going to assemble it with this, but I won't put it completely back together and give it back to Mum and Dad until I'm sure that it's safe. I would imagine if anything goes short circuit, whether it's a 3.1 or a 2.5, both fuses are going to blow. So yeah, I'm not sure. Anyway, I'm going to reassemble it now and we'll see if the thing works. I'm just soldering this little capacitor in first. You probably won't be able to make much out through the camera, and I don't think I'll film soldering all the parts in because This video is going long enough as it is. Okay, we'll put the new chip in. So all that side of the chip, all the legs are soldered on the one rail. So that's gone in quite well. I've had to buy a bit of heatsink compound, thermal compound, to put between the chip and the little heatsink. I didn't actually have any thermal compound. I guess the more experienced I'm getting at electronics, the more stuff I just have to buy. So our chip's now back on. I guess we probably should put the heatsink... Oh yes, we've got to solder the heatsink in as well. Okay, I haven't actually used this before. I guess we just smear a bit on the top of the chip. And now we can place our cover over the top. And obviously we'll have to make sure that seats. Looks pretty good. Let's just take it out and see if we have contact. Ah yes, that's good. Okay, now we can put our filter capacitors back in. I think they were both the same. 22UF 400, yes. And I checked them and they did test fine. Okay, let's make sure the polarity is the right way. Doesn't really matter which one goes where, I guess. I was just trying to line up where the silicon was. And negative on that side. Okay, let's solder those two in. Righto, we're repopulating pretty swiftly. Next we have probably the... Oh, let's put the varistor in. That goes across there. We're going to have to do a little bit of creative soldering to get the bridge rectifier because we lost a bit of copper track. I think that when the last one went pop, it actually fused a bit to the board, and when I took it off, it peeled some of the copper track off. But if we solder the varistor in, we can then perhaps build a bit of a solder bridge across there. Let's put our fuse in now as well. We'll put a bit of heat shrink over the fuse. Okay, so she's looking pretty complete on the top now, minus all the white silicon stuff. Okay, let's get this bridge rectifier in. Now AC to that side, plus minus to that side. I think we can get a bit of solder to bridge across that pretty easily. A little bit of a lead we clipped off the fuse, we might just use as a bit of a bridge. Be a little bit bulky, but I think it'll be fairly secure. Okay, we have our board back together. So we have, just double checking, we have the bridge rectifier AC side to line in the fuses across there. We've got our varistor back in. Positive rail goes through the inductor and round, and there's a filter capacitor across there. And there's another one straight across here. We've soldered all our main rail in alongside that IC chip. And I did look up the IC chip. It was a TNY 180, and it actually is a switching IC, and I think it incorporates a MOSFET, because switching power supplies use MOSFETs to switch. This doesn't have any, so they're actually in that little IC. Anyway, it's all back together. I guess the moment of truth is nearing, that we can put some power onto it, and hopefully we have no more explosions. Okay guys, it's the moment of truth. It's all back together. I've just wired the mains wires in. I've double checked everything. All my solder joints are okay. I haven't wired up the output wires yet, but I basically just want to turn it on and make sure it doesn't explode again. So if it does go bang this time, I am going to throw my arms in the air and throw this in the e-waste bin and give up. But I would appreciate any feedback. I'll still post the video, but perhaps let's not get too negative. Let's turn it on and see what happens. That was loud. Okay, it blew the fuse completely apart. I have no idea what's wrong with this thing now. Well, I give up. I don't know. Admittedly, I probably should have run it through a dim bulb, but you know, that really wouldn't have made any difference. The fact is that something's wrong and it's blown up again. Well guys, this is the end for this Dyson charger. I'm going to buy another one on eBay. This one's being thrown out. I'll probably scrap the transformer for a few cents. I'm not going to try and salvage the IC chip. It's probably blown. I don't know. If you know what's wrong with this, or at least what I missed, I might have overlooked something really obvious and just wasted my time and a few dollars in parts. At least they were expensive parts. I've learned a bit. I've learned a lot. And I think that's the good thing about these sort of exercises, is that we never come away empty-handed. We do gain some knowledge. I've learned to save some little fuses off circuit boards and even the bridge rectifiers, because I may use them in the future. I've learned a lot more about how switch mode power supplies work. So yeah, it hasn't been a wasted journey, but it's certainly been disappointing not to have a good result at the end. Anyway, it's been a long video. If you've stuck right through this, thanks for watching. If you've got some input on my electronics skills or lack thereof, or some insight into what else could be causing this, because the only other component in that primary side is the transformer, other than a couple of microscopic little resistors and diodes on the back that, and I did test the transformer and I got an ohms reading that I thought was reasonable. Enough about that. I'm chucking it away. Thanks for watching, guys. We'll catch you in the next video, where hopefully I will have success at something. See you then. Bye for now.